It's going to work 5 points each. Not for test reviews. So there are conditions to the homework. You cannot use them for test reviews. Okay, I guess I'll start over here, folks. Monday and Wednesday, section 45. What? Oh no. I can't shoot it out. Guys, if you already have that stuff, move on to the next one. The next slide.
No kidding.
No, you didn't say words.
No one said
Use words. I say do it with my last night first priority.
Yeah, I know. My work is not really warm. Yeah. If I can't understand it, I don't know.
Can I flip it?
Down arrows, down arrows and stuff.
Yeah.
For those of you who did not do the homework, when you get a bad grade on the test tomorrow, complain to me. Okay? These reviews, you don't just say do all of them. And there was a lot of them in this particular one, but that's because we say we need to stress these. Why? Can you express on the test, right? So. Yes.
I'll beat them all to the tennis, so I stick the test by.
We can talk outside of class. That's what I heard. Look.
It's your last test. Oh, I don't know.
Yeah.
I forgot.
Welcome to your nightmare area. Questions on the homework? I'm not going to spend a lot of time, only a couple of minutes at most on the homework.
For 41.
Okay, what about 41 in particular?
And number.
Okay. Gentlemen? So how do we find the number of turning points? Well, we start off with what? What is the degree of the polynomial? So in number 41, what's the degree of this polynomial?
4.
It's the fourth degree. Right? Don't forget, as far as if we're doing it's like we had on a quiz, right? I don't just take a look at, if I'm multiplying, I want to go ahead and do what with my exponents? I want to add. So here I have a first degree with a third degree. So I have a fourth degree polynomial. Number of turning points is always going to be one less. So in this case, we have 3 turning points. Right? You said turning points, didn't you? So we wind up with 3 turning points. Here's one, there, and there. We have the 3 turning points. Since the fourth degree, we know we had the end behavior similar to a quadratic or a squaring function, where both of them are rising. And then just by factoring it out, we get the zeros, or 0, 1, and negative 3. What? What is the 8? That's your remainder. Right, when you do your division, you should not wind up with a remainder of 0. Your last thing should be an 8. And you divide by, actually it'd probably be a negative 8, but you divide by your divisor. And always write your remainder over your divisor. That's probably just a small math error. All right, folks. So let's continue on. So, going back to our first quiz there. Here we have our f of x equals 3x cubed minus 15x squared plus 18x. We're going to sketch the graph. First things first, factor it out. Right? So, what do I want to start off with? I already passed them back there. Passed them back like last week. So, we go ahead and, what is the GC up here?
3x.
Sorry? 3x. Giving us x squared. What does that plus mean?
Same size.
Same sign. Some of you on the quiz gave me opposite signs, giving me a -6 and a +1. But here we actually come up with 3x times x minus 3 times x minus 2 is exactly 4. How do I find the zeros? Okay, say they're all equal to 0. And I know by the zero product rule, right, that my factors, I just set each factor equal to 0. So 3x equals 0 gives me x equals 0 with a multiplicity of x minus 3 equals 0. X equals 3. Multiplicity of 1 and x minus 2 equals 0. Giving me that 2. The multiplicity of 1. How do I determine the end behavior? My leading coefficient test. All right, we look at that degree, that highest degree of a 3. And is it positive or negative? Well, it's positive. Odd. So it resembles what? My cubic function, absolutely. Which does what on the left? False. And on the right? does not go up, it does not go down. It does not increase, it does not decrease. All those answers are unacceptable. It either rises or falls. So now what? Yeah, absolutely. So we take our zeros, 0, positive 2, positive 3. I know my end behavior, it's going to fall and rise. What do I know about my zeros with odd multiplicity and even multiplicity? Sorry?
Evens balance out.
Evens touch, and my odds cross. What are all these going to do? Absolutely. All these are going to cross. And I already know my end behavior. Do I know where that turning point is? Where the relative maximum are? Somewhere in between. Absolutely. So, however you draw just a nice, smooth, continuous curve. Again, using your end behavior, you'll come up with a graph similar to this. Here we have 5x to the 4th plus 15x squared plus 10. Should I do first?
Oh, it was, what was the huge stuff? It was,
Minus 15x squared. Thank you. So yeah, take out the 5, so we have our 5. X to the 4th minus 3x squared plus 2. Which is what? What is x to the 4th? X squared, right? Absolutely. X squared minus 2 times x squared minus 1. And the x squared minus 1 is so when we write down that factored form, we have our 5 What about my zeros? Again, we set the whole thing equal to 0. And we have each factor equal to 0. X minus 1 equals 0 gives me 1. Negative 1. What about that x squared minus 2? I'm busy. Not plus or minus 2, but plus or minus square root of 2, right? Again, solving for x. So we come up with that. All of them with a multiplicity of 1, right? Nowhere in there do I have x squared equals, or x minus a quantity, x minus a quantity squared or cubed. Everything is just x equals, so everything here has a multiplicity of 1. It's a 4th degree polynomial with a positive leading coefficient. What's the end behavior? Rises on both sides, absolutely, just like our squaring function. So now we have rising, putting down our zeros, negative 1 and 1, and where else? So negative 1.414213562337. Was that right? No. Roughly there. You guys can use anything in the classroom if it helps you, right? If I don't take it down, or if I do something else by accident, that's not cheating, that's my bad, right? So, now what? Using nice, smooth, continuous curve, do I have all the points needed? Can I find any additional points? If I can find the intercepts, also find the intercept. Can I find the y-intercept in this case? Yes. How do I find the y-intercept? Yeah, let x equals 0. So when x equals 0, So now we do have more fidelity to this graph, better understanding what it's going to look like. And that's what we come up with our graph of this f of x. Here we have f of x equals x squared times x minus 4 quantity cubed times x plus 2. What is the degree of this polynomial?
6.
How'd you get that?
It's x squared plus cubed plus, that's an understood one.
As Alex said, we take a look at all the exponents. I have a squared, I have a cubed, and I have a first degree. We add those exponents. So here we do have a 6th degree polynomial. 6th degree polynomial with a positive leading coefficient. What's that end behavior? What about my zeros? All right, we have that x squared equals 0, so I have 2 of them. I have a 0 and I have a 0, so as Karen said, we have that 0 with multiplicity of 2. And then I have x equals 4. Absolutely, with a multiplicity of 3 because of that. I have x minus 4 times x minus 4 times x minus 4, so I have 3 x equals 4s. And then I have just 1, negative 2. Again, what's happening at the x equals 0 on my graph?
It's touching.
It just touches. So, again, we know that the end behavior, we're rising on both. I have the 0, negative 2, and 4. At negative 2 and 4, we're crossing the x-axis, but at 0, we're just touching. And we wind up with a nice little double. Questions on the graph?
When we draw the graphs, do we have to have like exact points or can we just like sketch it?
Sketch it. But like in the last one, do come up with the intercepts, that exact point. Again, you're not going to know where these relative minimums are without using derivatives and stuff like that, which we're not going to over. So here, we're going to divide using synthetic division when applicable. When is it applicable?
X by itself, plus or minus the normal numbers.
Absolutely. Scott said when x by itself plus or minus, so x minus a. Anything other than that, it cannot do synthetic division. 2x minus 7 does not work. X squared minus 1 does not work. In this case, x minus 4 works perfectly fine. What am I dividing by?
4.
4. So I have my 4 using my synthetic division. What do I write for the coefficients? Absolutely. Don't forget that placeholder for the x term. What's that? So now what do? Drop down to 5. 14. 4 times 14 is 56. What is my 232? Remainder. So what is 5, 14, and 56? Plus 14x plus 56. That's it. 232 over the divisor. X minus. This is the division problem. This is what they asked us to divide. And that's what you come up with, the quotient plus the remainder. And number 5, what do I use?
Regular division.
All right, here we have to use long division since we had that 4 out in the front. So first things first, how do I transform the 4x into 4x cubed? Multiplying by x squared, all right. Do what now? Change the signs, either subtracting. So now I need to, what do I multiply 4x to get to that negative 12x squared? Am I done? No. Some of you did give me just x squared minus 3x. Again, if I still have a remainder, if I still have something that is the same power or higher, I keep on dividing. I stop only at 0 or if my divisor is the larger degree. So what do I do for 4x plus 5? Plus 1. Change the signs, come out remainder 0. So here, the solution is just that quotient. There is no remainder. It just has the x squared minus 3x plus 1. Questions on our division? This one got a lot of you here. If you guys remember, this was where you're actually using something called the remainder theorem. The remainder theorem states that we can evaluate f of k by dividing, using synthetic division, dividing by k, and whatever the remainder is, that's my answer. F of k equals that remainder. So here, I have f of negative 5 I want to evaluate using synthetic division. So I drop down my 3. So I have a remainder of negative 199. So this tells me that doing this wasn't too bad, synthetic division, right? However, if I wanted to evaluate negative 5 by plugging it in, then I'd have 3 times the negative 5 cubed plus 5 times the negative 5 squared. So a lot of times just evaluating that particular number becomes astronomical. It becomes a very big number that we're dealing with, where that synthetic division works a lot of times a lot faster and a lot easier, right? Even with fractions. So here I'm using 1/3. Drop down to 3. 6 times 1/3. And this is the only time that you have to do any manipulations with your fractions, right? You get negative 8/3. 1 minus 8/3. Negative 5/3. Yes, 1 is just what? 3 over 3, so 3 minus 8. So we got negative 5/3 as the remainder. That's all there was to this problem here, folks. Questions? Not too many issues here on 7 through 10, the complex numbers. Other than a lot of you did not pay attention to the writing it in standard form. What is standard form? A plus bi, the real part, and then the imaginary part in stereo. So, what do I do with number 7? What is that 5i squared? Right. That I squared to negative 1, so I have a negative 5 and a negative 6i. We write as negative 5 plus 6i. Just making sure you get it. What about number 8? What do we have to do there? Absolutely. Don't just look at that 2 plus 3i and say, okay, it's just the first term squared with the second term squared. If it helps, write it on out as so right. We want to FOIL it out, giving ourselves 4. So now the 9i squared is negative 9. So negative 9 with our 4, giving us so adding complex numbers, we're just adding our real parts with our real parts, imaginaries with imaginaries, giving us and number 9. Multiply by its conjugate. Absolutely. When I have it a complex number in the denominator, multiplying by its conjugate, 2 plus I, top and bottom. So once again, numerator, we need to multiply it out, FOIL it out, giving us 6. All right, so plus the 8i and plus the 3i, so 11i. There. Minus 4 plus 4i squared. Denominator, when I'm multiplying conjugates, what do? I don't have the outer and inner, right? It's just the first term minus my last term squared. So it's just going to be 4 minus I squared. That's the nice thing about this conjugates, right? The top simplifies. Right, because then minus the plus 4i, or the plus 4i squared, and I squared is a negative 1, so negative 4 with 6, right, 2 plus 11i. Denominator, 4 minus a negative 1, 5. Am I done? Still not in standard form. Yeah, absolutely, 2/5 plus 11/5 I. Questions on that? And then on to the last one, the tough one. Very challenging here. Multiple steps involved. You have to be very meticulous. So we have our 12 minus 6, our real part, plus our 5 minus a negative 8. I, 12 minus 6. And no, folks, you didn't have to show all this. 12 minus 6, 6. On to the next quiz. If we have time, we'll come back and look at all of these. Meantime, we'll just start off with looking at number 1. Make sure you read the instructions, you read the directions. This particular one, 1 through 4, it asks for how many different things? 3, 4. Some of you only gave me 3 answers when it asked for 4. Here it asks, give me the positive zeros from discards, the negative zeros, possible rational zeros, and then all of the actual zeros. So there should be 4 different parts to each problem here. So starting off with our discards using our positives. Counting up the sign changes. 3 or an even number less. 1. Negative. I'm sorry? 0. That's what it is. How do we know we got 0? So which one's signs change? Exactly. So here I had a negative change, so we can see that everything is negative, no sign changes. So now what? Our possible rational zeros. What should we get by doing what? Our factors of our p, or factors of q, p being my constant term, q being my leading coefficient. Leading coefficient of 1, so we can ignore that and just take a look at the factors of our constant. 6 giving us you guys can ask me, I know you asked me about, but you can remind me afterwards and I'll give you that point back. So, and as some of you noted there, which I saw after the fact, since we have no negative real zeros, of course we don't have any negative in our possible rational zeros, so it would just be positive 1, positive 2, positive 3, positive 6. So now we only have 4 choices for our rational zeros. What should we do? All right, use synthetic division. Where should we start off at? 6?
2.
I'd start off at 1. Again, folks, let's take a look for patterns, right? If you take a look at just the coefficients, -6, -6, which is what? -12, positive 11, and I have an x cubed. So if I have that as a positive 1, I know I should wind up with 0, right? So if we do our synthetic division with 1, do you have to do that? No. Choose wherever you want to start off with, right? And hopefully you come up with that remainder of 0. So So here we came up with the remainder of 0, so I know that x equals 1 is one of my zeros. What do I do to find the other 2? Keep doing synthetic? I have myself a quadratic, so I can just simply write this out and factor it. If you wanted to, you can keep doing synthetic. It's a lot more guesswork involved. But here, that 1, -5, -6, what is that? Again, we're looking for the 0, so set n equals 0. So we get x equals 2, x equals 3, and we already used x equals 1. Questions? If we have time, we'll come back and look at 2, 3, and 4. So here we're going to find all the zeros of f of x equals x cubed plus 4x squared plus 14x plus 20. We already gave you 1 0. It's a third degree polynomial. How many zeros am I going to have?
2,
3. Right? I'm going to have 3 zeros. So my answer should have how many things should I have for my answer? 3. That'll be only give me 1 or 2. That's for all the zeros, so make sure you list all the zeros. Even though they gave you 1 at 1 minus 3i, what is the other? -1 plus 3i, the conjugate, right? So what do I do now? So I can use my synthetic division. So I drop the 1. So now I have 3 minus 3i. What do I need to do? Multiply. Exactly. FOIL out. Double distribution. My 3 minus 3i times -1 minus 3i. Giving us what? FOIL it out again, absolutely, in a negative 20, coming up with a remainder of 0. If you did not come up with a remainder of 0, what does that mean?
It's not back there.
Well, they told you it was a 0. Right, go back and check your work. Perhaps when you followed it out, you messed up somewhere, you did a plus or a minus or something like that. Go back, check the work. Don't just say, okay, I came up with a remainder of 17, and go on to the next one. No. I have myself what now? Quadratic. So that's not a quadratic we can easily solve. So what do? Use the conjugate, the other 0. And usually the second time you do it, things cancel out quite a bit, so it does become a lot simpler. So dropping down to 1. That way. So what do we have left now? If I'm looking for the 0, again, I set it equal to 0. This is not x equals 2, it's x plus 2. So looking for the 0, I get x equals negative 2. So it lists all the zeros. I have x equals negative 2. X equals negative. Right, that's my answer. Question? Number 6 is the one that got most. Even though we had this in homework, and I actually did one of these in class. So find a polynomial with integer coefficients that has 5 plus 2i and negative 3 as zeros. So, what degree polynomial is this going to be? A third, but it only gave us 2 zeros. We always know that complex zeros come in pairs. So we also have that minus 2i. So I have those are my zeros, right? But I'm looking for this polynomial, so what do I need to do? Well, first I need to write it in what form? So put it in factored form, right? So my x equals negative 3 becomes, and my x equals 5 minus 2i, x minus, and my, again, x minus that 0, so x minus, right? A lot of you just gave me 5 minus 2i times 5 plus 2i. Completely ignoring the x's. Factored form, it's always x minus at 0, even if it is a complex number. So now, simplifying that, distributing the negative, we have our x plus 3. And this is where the fun begins, right? What do we do? All right, take care of the 2 trinomials. How do I multiply the 2 trinomials? Distribution method, right? So just starting off with x, multiply it to each of the 3 terms in the second trinomial. So x times x, x times negative 5, so we've taken care of the x. So now we move on to the negative 5. I'm sorry? So minus 5x plus 25 plus 10i. So now we're just left with taking care of the absolute, taking care of the plus 2i. So plus 2i times x left-like terms cancel everything that can be canceled and just simplify. So 2ix's are gone, and the 10y's are gone. All right. So now we have our x plus 3 times x squared minus 10x by minus 4i squared. That I squared is a negative 1, becoming a plus 4. So we get that plus 29. And finally, now we have a binomial times a trinomial, so this step is a little bit easier. There's no i's involved. Once again, using the distribution method, x times x squared, x cubed. Well, you can do that, but I'm going to take my x first. So minus 10x squared. And then using my plus 3. This problem was a little bit lengthy, but was it difficult? No. Lots of multiplying. Lots of using distribution. Or that's all it was. So here, you guys really didn't have any problems on these, number 7 and 8 overall. So I'm going to state the domain, come up with the intercepts, asymptotes, and find the graph. So how do I find the domain of a rational function? So my domain is all real numbers except for 4. By finding that domain, what did we also find? Vertical asymptotes. What is my vertical asymptote? Absolutely. It is where that domain is equal to 0. X equals 4. It is not v equals 4. It is not 4. Right? My asymptotes are lines, so it should always be x equals or y equals. Right? So for my vertical asymptote, x equals 4. For my intercept, to find my y-intercept, what do we do? What do we get? That's right. If you set x equals 0, we're left with a 1 over negative 4. What about my x-intercept? To find the x-intercept, we let what? Numerator equal to 0. So when is 1 equal to 0? Never. So there is no x-intercept. We still want to find our horizontal asymptote. So we compare what? We compare degrees. In this particular case, my numerator has a degree of 0. Denominator has a degree of 1. So my denominator has a larger degree. So we know we're in the case of y equals 0. So plot our 1 point, 0, negative 1/4. Asymptotes at x equals 4. And y equals 0. What should I do now? Well, we still need to get one more point as far as we don't know if we have a piece over here or a piece of the graph over here. So take something like that, x equals 5, coming up with a point, say over here. So now we know that we have a function like this. Right. Questions? For number 8, what is my domain? Okay. We find out where the denominator is equal to 0. It cannot equal 0 at x equals y. It's going to equal 0 at x equals negative 1, which also tells us our vertical asymptote is x equals negative 1. Intercepts, y-intercepts again, I'm letting x equal 0. So the zeros would be gone, and it just has a 5 over 1, right? Make sure you can define the, I'm sorry? Absolutely, x-intercept, I set the numerator equal to 0. I'm sorry? Absolutely, we get x equals negative 5/2. 0. And then lastly, to find that horizontal asymptote, comparing powers again. Here I see that our powers are what? They're equal, they're the same. Right? Numerator is equal to the denominator. I had the case n equals m. So that tells us to do what? Leading coefficient over leading coefficient. Is 5 the leading coefficient? It's going to be my 2 and my understood 1. So now we go ahead and plot what we have. So 0, 5, negative 5/2, 0. And our asymptotes equals negative 1, y equals 2. And that's the graph we come up with. Questions? Questions in general? No, folks. Don't wait until tomorrow and say, hey, I didn't understand this.
How do you find the y-asymptote again?
How do we find the to find our horizontal, right? We have our we always compare finding our horizontal asymptotes, folks. We always compare what? And then the highest degrees, right? So if I have n is less than m, my denominator is the larger one. And n equals m. However, if this is the case, what do I have to look at? Right. So in this case, right, if I have my numerator is 1 power higher than my denominator, I now have a slant. It's a slant asymptote. And how do we find the slant asymptotes? We divide. It may not be synthetic division, folks. We divide. It's only going to be synthetic division if my denominator is x minus something. Right? It may be long division, but we're just looking at the quotient. We're not looking at the remainder at all. Any other questions, folks?